Okay, so we'll go ahead and start with number 49 and 9.3. So you're given negative 22 degrees Fahrenheit, and you need to convert to Celsius. Oops. All right, so since you're given Fahrenheit, you want to use the formula C equals 5/9 times parentheses F minus 32. So substituting in the negative 22, if you have the formula with the parentheses, then you have to do what's inside parentheses first. So we're going to go ahead and subtract, but notice that both the numbers are negative. So that means that you're really adding and keeping the sign. So we get negative 54. All right, so notice in your problem you're multiplying now, and you've got a positive fraction times a negative number. So that means your answer is going to be negative. And then you have some options. You can multiply first or divide first. It's up to you. But let's see, 9 goes into 54 evenly 6 times, and so we have 5 times negative 6, which is negative 30 degrees Celsius. Yeah, it's the same answer. You could do 5 divided by 9 and then times negative 54. You know, if you're using your calculator to do all of it, your calculator's not always that smart. It doesn't always know order of operations and so on. So, you know, you have to do the process of order of operations in your calculator. Sometimes you might have to do 5 divided by 9 and hit equals first and then multiply it by 54 to make sure that you get the right thing, you know, making sure that your calculator, you know, it understands what you're trying to do and so on. Okay, and it all depends on the calculator. Every calculator is different. Then number 73. It says for each kilogram of a person's weight, so this is similar to the one I did in class, .5 milligrams of a drug is to be given. What dosage should be given to a child who weighs 80 pounds? Okay, so we know that for each kilogram of a person's weight, 2.5 milligrams of a drug is to be given. And we have a child who weighs 80 pounds. Okay, so your dosage is based off the weight of the person, but it's also based off kilograms, and you were given pounds. So the first thing you have to do is convert the child's weight. All right, so looking at what we know about pounds and kilograms in the textbook, we know that 1 pound is equal to 0.45 kilograms. All right, so starting with 8 pounds over 1, then that tells us that pounds has to go diagonal, kilograms up top. Again, the beauty of dimensional analysis is that you never have to wonder, am I supposed to multiply or divide? Because if you set up your fraction properly, it will set up, you know, what you're supposed to do. So 0.45 kilograms over 1, showing us that we have to multiply 80 times 0.45. Okay, so 36 kilograms. And now we have to figure out how much to give the child. Now again, if you're not sure whether to multiply or divide, you can still use dimensional analysis for this part, because it tells us for each kilogram, so for 1 kilogram, we're supposed to give 2.5 milligrams of the drug. So now we're starting out with 36 kilograms over 1. So kilograms had to automatically go diagonal, showing that we have 2.5 over 1. So then multiplying by 2.5, we get 90 milligrams exactly. Now technically this is an approximated amount because our original conversion was approximate. It was approximately 0.45 kilograms. So if you see that squiggly equal sign, it means it's not exact because the conversion we used wasn't exact.